We're going to solve another example problem, solving for unknown forces acting on an object. And in this problem, there's more than one force acting in some direction, so it makes it a little bit more difficult. But this process is just the same as the example problem we did the other day. In this problem, my husband and I pull a piano with a mass of 190 kilograms at a constant velocity. I can pull with a force of 23 newtons, and the force of friction resisting the piano's movement is 50 newtons. How much force must my husband use to pull? The first step is to make a force diagram, and if you're not sure of how to do the force diagram, always just start with the system schema. If you feel confident you're not going to miss any forces, then you can go straight to the force diagram. I will do system schema first. So first we're going to have circle of P for the piano. We'll have a circle to represent me, a circle to represent my husband. We've got the ground, and as always, the entire Earth. Do the easy one first. The entire Earth interacts with everyone, everything, through the force of gravity. Get all those in there. And remember, they're dashed lines because that's representing that force of gravity is a non-contact force. Things do not have to be touching. Next, I look at what is touching. The piano is touching me. I'll call that a normal force. I'm kind of assuming my hand is flat on the piano, so we have two surfaces touching. The piano is also touching my husband's hand, and again, it'll be a normal force for the same reason. The piano is touching the ground. There's going to be two forces there, the normal force keeping it from falling through to the center of the earth, and also the force of friction. There's nothing else touching the piano. We could also make a connection between myself and the ground and my husband and the ground. Those would be normal forces and frictional forces. Now, if you didn't put those in, that would probably be okay, because we're not going to do a force diagram for myself or my husband, but if you did want to do one of those, you would need to make sure those arrows are present. We're going to focus on the piano because that's what we know the most about. We know its mass, and we know several different forces acting on it. And if I look at this force diagram, it looks like I've got 5 interactions coming in and out of that circle representing the piano. So my piano's force diagram should have 5 different forces on it. So piano. Again, I'll draw a dot that represents the piano itself. We have the force normal on the that I apply to the piano. We have the force normal that my husband applies to the piano. We have, and I decide on those directions for those previous force normals because they're perpendicular to the surface where my hand is touching the piano. Where this force normal that the ground applies to the piano, it's going to be straight up and down because it's perpendicular to the ground. The force of gravity will be towards the center of the earth. And finally, the force of friction is going to be the opposite of the direction that the piano is moving. So force of friction that the ground applies to the piano. Now that we've got my force diagram drawn, we can write net force equations for both the x direction and the y direction. I'll start with the x direction, the sum of the forces in the x direction. And again, I've got my choices. It's either equal to 0 or not equal to 0. In the problem, it says clearly that the piano is moving at a constant velocity. That tells me that the forces in the x direction have to add up to 0. If I think about the forces in the y direction, well, the piano is not leaping up and down or moving at all in the y direction, so that's a 0 velocity, which is constant. And so again, the y forces will add up to 0. Now the question I'm asked here is how much force must my husband use to pull? And his force is in the x direction, so I'm going to worry about forces in the x direction to answer this question. I said they have to add up to 0, so I'm going to write an equation for all the actual forces that I have in the x direction. We've got force normal that I apply on the piano. We have also the force normal my husband applies on the piano. Those are both positive because they're pointing in the right direction, the way I've drawn them on my force diagram. And then we have minus the force of friction. That's negative because it's pointing the opposite to the left in my picture. And those all add up to 0. Now I'm going to substitute in the numbers that I know. I know that I pulled with a force of up to 23 newtons, so I'm going to put 23 in for the force normal that I apply to the piano. I don't know the force that my husband applies to the piano, so I'm going to leave that in as a variable. You could also put in an x if you prefer that. I do know the force of friction. It says in the problem, the force of friction opposing the piano's movement is 50 newtons, so I'm going to put minus 50 equals 0. Collect like terms. 23 minus 50 is negative 27. And again, I've still got the variable in there for my husband's force. I'm going to add 27 to both sides. And I have determined that the force my husband applies to the piano is equal to 27 newtons. Now you can also ask a question about the y direction, and that's exactly what I do on the next slide. What is the normal force applied on the piano by the ground? We're going to take a look back here. Now I'm concerned about the forces in the y direction. They still add up to 0 because the piano's not moving in the y direction. So y direction is what I'm concerned with now. Going to write an equation showing the sum of the actual forces on my picture. I've got the force normal up that the ground applies to the piano. Force normal that the ground applies to the piano. And then the other force in the y direction is the force of gravity. The entire earth applies to the piano. I'm going to subtract that because it's pointing down while the normal force is pointing up. So those two should add up to 0. Now, if I look back at my original problem, I do not know the force normal. I do not know the force due to gravity. I do, however, know the mass. And we learned earlier this week that you can calculate the force due to gravity by using the equation mass times little g. The mass was 190 kilograms. 190 kilograms. And little g is 9.8. So the force due to gravity is 190 times 9.8, 19.39 newtons. I'm going to take that number and substitute that in for the force due to gravity in this equation I wrote over here. So force normal that the ground applies to the piano minus 19.39 equals 0. Add 19.39 to both sides of the equation. I find that the normal force is equal to 19, I'm going to round off just one fewer decimal place, 19.4 newtons. That is my final answer.